Right now, at this exact second, to generate the words appearing on your screen, a machine in a data center 1,000 miles away is, well, it's literally boiling industrial liquid just to keep from melting down. Welcome to the deep dive.
Thanks for having me. Yeah, that's such a striking image.
It really is. I mean, we have this tendency to think of the internet as this fluffy, weightless cloud. You type an email, you ask an AI a question, and it just kind of floats up into the ether and returns an answer.
Right, like magic.
Exactly. But when you pull back the curtain, you realize there's absolutely nothing weightless about it. Our mission today is to uncover the hidden physical reality behind our screens specifically, how data center electricity actually powers the manufacturing of sentences through token processing.
Yeah, and it is entirely physical. Every digital action you take, it triggers this massive, heavy industrial reaction in the real world. We ask a question, an answer appears, and we never really have to confront the sheer tonnage of machinery, the raw megawatts of electricity, or, millions of tiny switches that physically had to flip to pull that off.
Which is why the source material for this deep dive completely shattered my understanding of the internet.
It's a great document.
It really is. We are looking at a document simply titled Data Center 101. And the fascinating part is that it isn't written by, like, a software engineer in Silicon Valley. It's written by a commercial real estate broker.
Which brings such a refreshing, grounded perspective to the topic. A commercial real estate broker doesn't really care about the tech industry hype cycle.
Right. They don't care about the shiny new app.
Exactly. They care about the physical footprint of the building. They're looking at the concrete, the power grid demands, the industrial cooling systems, local tax laws, and the actual physical mechanics of just keeping a massive structure from catching fire.
And he applies what he calls the Mrs. Videsis test.
Oh, I love this part.
Yeah. So Mrs. Videsis was his fourth grade teacher who famously told him, if you can't say it simply, you don't understand it.
A very harsh but fair rule.
Right. He realized his own local community was fiercely debating whether to approve a new data center, and almost no one in the room could actually explain plainly what happens inside one of these massive windowless buildings.
And that's so common right now.
So our mission today for you, the listener, is to take that test. We are going to uncover the hidden physical reality behind our screens. Okay, let's unpack this. Let's take the journey of a single keystroke.
It starts the instant your fingertip presses down on the plastic. The moment you press a key, you're interacting with brute physics.
Just actual moving parts.
Exactly. You are physically closing a tiny electrical switch underneath that keycap. A voltage changes. A microprocessor in your keyboard notices the drop in resistance, and suddenly the letter you just typed is translated into a short burst of electrons. It becomes a heavily coded pattern of ons and offs.
Okay, so your computer grabs that burst, bundles those electrons up into a package, and hands them to your router. And here is where we hit the first crazy transformation.
Yeah, this is where it gets wild.
The router takes those raw electrons and converts them into flashes of light, and then fires them down a strand of glass fiber that is roughly the width of a single human hair.
Your question literally changes delivery trucks. It moves from traveling as electrons in copper wire to traveling as photons of light in glass.
And the speed of that light is staggering.
It is. Light traveling through glass fiber moves at roughly 124,000 miles per second.
There is nothing on the surface of the Earth that far away. In a single second, your question could lap the planet 5 times.
Easily.
The author points out that if your question is heading to a data center, say 140 miles away in Denver, the round trip through that fiber takes about 1/1000th of a second. Just to give you a comparison, a human eye blink takes 300 times longer than that.
The travel time across the country is practically a rounding error at that point. Your question spends far more time waiting for your human finger to physically lift off the keyboard than it does crossing 2 state lines.
The source has a great analogy for this. The fiber optic wire is not the holdup. It's a freshly paved country road with absolutely no traffic on it.
Right.
But wait, I have to push back here. If the fiber optic cable can wrap the Earth in a second, why am I staring at a blinking cursor for like 4 or 5 seconds when I ask an AI a complex question?
That's the logical next question.
Yeah, if the wire isn't making me wait, the math simply doesn't add up. What is actually chewing up all those seconds?
Well, the delay you experience happens entirely at the destination. You've raced down the country road in a fraction of a millisecond. But what happens next depends entirely on which door your question walks through at the end of that road.
Okay, so there are different doors.
Yeah, to pass the Mrs. Videsis test, the industry has essentially built two completely different types of destinations. Let's call them the fetching door and the manufacturing door.
Let's look at the fetching door first.
The fetching door is the classic librarian. Think of traditional Google search. It is a librarian overseeing the world's fastest card catalog. Long before you even sat down to type your question, software spiders crawled the internet, read billions of web pages, and neatly filed them away in an index.
So the work was already done.
Exactly. When your flashes of light arrive, no new thinking occurs. Nothing new is written. The librarian simply takes your words, matches them against its massive catalog, and fetches the closest existing shelves.
And the physical cost of that transaction is almost nothing. The source notes that fetching a search result takes a few tenths of a second and uses a minuscule amount of electricity, about 3/10 of a watt-hour.
Barely registers.
It's incredibly cheap on a physical level, which is why it's free to you. Although we should probably put free in heavy quotes.
Yeah, definitely quote-unquote free.
Because it's free because the answers aren't actually the product. You are the product, your eyeballs, your data, and your attention. The search is free in the exact same way the cheese in a mousetrap is free.
That's a perfect way to put it. But the entire digital economy is currently shifting toward the second door, the manufacturing door. This is artificial intelligence. Unlike the librarian, AI does not fetch existing documents. It manufactures entirely new ones from scratch.
And every factory needs a raw material to work with. If a lumber mill uses logs, what does the sentence factory use?
So in the AI factory, the raw material is called a token. When your question hits the data center, the machinery takes your English words and chops them up into these tiny standardized pieces.
Tokens.
Right. The author describes a token as a basic bookkeeping unit. He calls it language's square foot.
So if you type a prompt like, sell my building, the machine chops that into roughly 4 tokens.
Simple enough.
But if you throw a massive complex word at it, like windbaggery, the machine doesn't view that as one piece. It fractures that single word into 3 or 4 separate tokens based on syllables and common prefixes.
What's fascinating here is how the AI actually utilizes those tokens. Because it isn't looking them up in a pre-written file cabinet. It runs them through a neural network that has been schooled on a massive share of everything human beings have ever written and digitized.
It's read basically everything.
Yeah, but it didn't memorize individual facts from those books. It learned statistical patterns. It learned which words historically follow which other words, how a persuasive argument is structured, or even just the rhythmic cadence of a good joke.
The author makes a brilliant real estate comparison to explain this. He says after 40 years in the commercial property business, he can walk into an empty office building and, quote, "you a highly defensible rent price strictly from his gut."
He just knows.
Right. He doesn't need to sit down, pull county records, or check recent comps. His brain has absorbed decades of invisible variables, and he just uses pattern recognition to generate a number. AI is doing exactly that, just scaled up to an industrial level. It composes answers the way an experienced broker prices real estate from a highly educated gut.
Which, comes with a very critical warning for anyone using it.
Yeah.
Because it is working purely from gut pattern recognition and not from a factual filing cabinet, it has the capacity to be brilliantly, intuitively right. But it can also be confidently, spectacularly wrong.
Yeah, the classic AI hallucination.
Yeah, exactly. Factories are designed to manufacture things. They aren't designed to check the shelves to see if the thing they just built is actually true.
Okay, so we know AI manufactures answers by the token, but this is the physical deep dive. We need to actually step onto the factory floor to see how raw megawatts of electricity are physically transformed into these tokens.
Let's do it.
Let's trace an actual question into the building. Say you prompt the AI, how do we become the safest city in America?
Okay, that prompt breaks down to about 10 or 11 tokens. Once those flashes of light arrive off the fiber optic line, they convert back into electrons and enter the processing floor. And the physical environment inside is just wild.
Describe it for us.
The building is lined with endless rows of massive steel racks, each roughly the size and weight of a commercial refrigerator. Inside those racks are the servers, slotted in one above the other like flat pizza boxes.
And inside those pizza boxes is the crew running the factory. You have the CPU, the central processing unit. Think of the CPU as the factory foreman. It directs traffic and runs the place, but it doesn't do the really heavy lifting.
Right, it's management.
Then you have the HBM, high bandwidth memory. That acts as the workbench, keeping all the necessary data parts within an arm's reach of the worker so nobody has to walk across the room. And finally, you have the line workers themselves, the GPUs. Graphics processing units.
The GPUs are the absolute beating heart of the modern AI data center. You have thousands upon thousands of them inside these servers designed to do the exact same arithmetic simultaneously.
Here's where it gets really interesting. These GPUs are arguably the most important, most expensive machines in the entire modern global economy right now, but they were originally invented decades ago so teenagers could shoot video game zombies with better frame rates.
It is hilarious when you think about it.
It is. Processing complex 3D graphics required doing a lot of simple math all at the exact same time, which just happens to be the exact same skill required to process human language. History has such a weird sense of humor.
It really does. But running thousands of these heavily modified zombie hunting chips to process language, well, it requires an unimaginable amount of physical infrastructure. The author breaks down the three massive systems that keep this factory from collapsing.
Okay, what's the first one?
First is the electrical system. We are talking about dedicated substations, massive step-down transformers, and rooms full of battery banks. A factory that eats tens of megawatts of power cannot tolerate even a millisecond flicker of an electrical outage.
Because the whole line would crash.
Exactly. Second is the mechanical system. Every single watt of electricity that comes into that building to power those chips has to leave the building as heat. The law of conservation of energy demands it.
Right, energy doesn't just disappear.
If you let that heat linger in the room, the machines will instantly throttle down and quit in protest to save themselves. But these new GPUs run so incredibly hot, and they're packed so densely into those pizza boxes that just blowing cold air over them doesn't work anymore.
It's not enough.
Air is actually an insulator. It can't carry the heat away fast enough. So they have to bolt industrial liquid cooling systems, basically closed-loop radiators, pumping specialized fluids directly onto the silicon chips themselves.
That is intense. And the third system?
Third is the control system. There are thousands of sensors constantly monitoring humidity, electrical loads, fluid pressures, and ambient temperatures, acting as the building's central nervous system to keep everything in perfect balance.
So synthesizing all of this physical reality, a data center isn't really a computer lab at all. When you strip away the Silicon Valley tech mystique, it is basically just a massive municipal electrical panel bolted to an industrial HVAC system with a tiny bit of computing tucked inside as an afterthought.
That's really what it is. The computing is just the spark that justifies the cooling. If it requires boiling liquids and massive megawatts of power just to keep these line workers from melting, we have to look at how the actual math of converting electricity into tokens works. Like, what is the actual labor happening on that factory floor?
The author affectionately calls this the mushing around.
Mushing around.
When your 11 token question, how do we become the safest city in America, arrives at the GPU, the machine doesn't read English. It converts those tokens into fixed catalog numbers. So the word how might be assigned entry number 8,472. The word city might be 913.
Your profound civic question has been flattened into a short list of coordinates. Now, the machine's entire knowledge base, everything it learned reading the internet, is also just stored as numbers.
Okay.
Imagine a massive multidimensional map where related concepts are grouped closer together.
Like a giant constellation of words.
Exactly. The GPUs take your list of numbers and perform billions of arithmetic operations, multiplying and adding them against the coordinates on that map. They're essentially testing distances, calculating probabilities to find the closest statistical neighbor to the words you just typed.
And doing those billions of calculations consumes a massive surge of electricity. And after all that intense mathematical mushing around, out drops exactly one thing.
Just one thing. The single most likely next token.
Just one piece of a word. It takes all that power, all that cooling, just to guess the first syllable of the answer.
And then the entire assembly line resets and runs the whole calculation all over again. It factors in your original question, plus the brand new token it just generated, to calculate the probabilities for the next token after that.
Over and over.
It repeats this billion calculation loop for every single piece of every single word in its answer.
Which completely explains a phenomenon we've all seen 1,000 times but never really understood. When you ask an AI a question, the text appears on your screen word by word. I always assumed that was, a cute artificial typing animation programmed in to make the software feel more conversational and human. But it's not a delay tactic.
Not at all.
You are literally watching a live industrial assembly line at work. The factory is shipping the finished parts back to you as flashes of light, converting them to electrons, and rendering them as pixels the exact millisecond they come off the line.
You are watching real-time manufacturing. And to understand the scale of this, we need to look at the ledger. We need to look at the economics of this live assembly line, because the physical costs are staggering while the margins are fascinating.
It's talk money.
So the raw electricity required to run those billions of calculations for a single AI answer is actually quite small per question, somewhere between 1/1250th of a penny and 125th of a penny. You couldn't even buy a stick of gum with the raw power cost.
But then you look at what the companies charge developers for access. Tokens are sold wholesale for anywhere from 10 cents for an easy million tokens up to $50 per $1,000,000 for the highly complex premium models.
That's quite the markup.
Yeah, and because the system has to process your entire input prompt but then run a full power-hungry trip down the assembly line for every single output token, making the answer is the real expense. Output tokens cost 3 to 6 times more to manufacture than the input tokens you send it.
The massive markup between the fraction of a penny spent on electricity and the dollars charged at wholesale, well, it doesn't go to the local power company. The true heavy cost of this sentence factory isn't the monthly utility bill, it's the physical machines sitting on the floor.
The GPUs.
The GPUs. They cost more than the steel and concrete of the building itself. A single rack of these chips can run into the millions of dollars. And here's the brutal economic kicker for the industry. Because the technology is advancing so rapidly, those incredibly expensive chips go completely obsolete roughly every 3 years.
3 years, that's nothing for heavy infrastructure.
Right. The industry is trapped in a cycle of constantly borrowing billions of dollars just to rip out the old machines, scrap them, and plug in new ones.
Because the hardware expires so fast, and because the chips demand so much raw electricity to do all this mathematical token mushing, it has fundamentally turned the entire global commercial real estate market upside down. Which brings us to the two completely different jobs these factories perform and why they are hunting for very specific types of cities to build in.
Yeah. So the industry divides the physical real estate into two categories: training and inference.
Okay, what's training?
Training is the schooling phase. This is where they feed the blank machine almost everything humans have ever written to adjust its billions of coordinate settings on that giant map. This phase takes uninterrupted weeks or even months. It costs hundreds of millions of dollars in compute time, and it happens on massive gigawatt-scale campuses.
Gigawatt.
Yeah, we were talking about facilities whose footprints are measured in square miles. It uses a whole town's worth of power continuously just to produce one single graduate.
But inference is the day job. Inference is when you sit at your laptop, ask that graduate, C-spot run, or how do we become the safest city in America?
Yeah, that's inference.
It's putting the trained model to work for a fraction of a penny at a time for millions of concurrent users. And because inference requires running those billions of probability calculations on the fly for every single word generated, it still requires heavy infrastructure, but it happens on a microscale compared to training. A 50-megawatt facility can easily handle the day job of inference.
This deep physical distinction dictates exactly where these factories are built. When a commercial broker looks at site selection for an inference data center, geographic distance to the user basically doesn't matter.
Because of the fiber optics.
Exactly. The travel time across a state or two is literally the speed of a hummingbird's wing beat. So these massive sentence factories do not need to be built near their actual customers. They don't require highway access for shipping trucks like an Amazon warehouse, and they obviously don't need foot traffic like a retail store.
So what are they actually looking for? They need spare megawatts. First, last, and always. They need heavy fiber optic trunk lines buried in the dirt. They prefer a naturally cool climate to help offset those massive liquid cooling bills. And above all, they need a local utility company that actually answers the phone and can guarantee steady grid capacity.
Power is everything.
Power has become the ultimate bottleneck for this entire revolution. I mean, the grid constraint is so severe that Chevron is currently building a standalone off-grid power plant in Texas exclusively for Microsoft to use, just for them. So what does this all mean for you, the listener? When a mid-sized city gets courted by a massive data center developer, what is actually happening behind closed doors?
This raises an important question about civic arithmetic. A city isn't being courted for its beautiful mountain views, its educated workforce, or its local customer base. A city is simply being courted for its electrons.
Just raw power.
The local government is essentially selling its spare power capacity on the global market. But the real municipal windfall comes back to that 3-year obsolescence cycle we talked about.
Oh, the hardware tax.
Yes, because the factory has to repeatedly rip out and replace all of its incredibly expensive GPUs. The city collects a massive use tax on all that newly imported hardware every 36 months. It is an ongoing infrastructure and tax boom that economists are comparing to the build-out of the early American railroads.
It's just wild to conceptualize. A city is trading its spare electrical capacity and local water rights for an endless cycle of hardware replacement taxes. It really grounds this whole abstract AI revolution in dirt, concrete, copper, and tax law.
It completely demystifies the cloud. It strips away the magic and replaces it with heavy mechanics.
Let's do a quick recap because the physical journey we just took you on is incredible when you view it end to end. You press a plastic key, that physical motion closes a mechanical switch, creating a sudden burst of electrons. Those electrons hit your home router and transform into flashes of laser light. That light races across the country entirely unimpeded down an empty glass highway to a windowless building that is essentially a giant industrial air conditioner attached to a municipal electrical substation.
The pizza boxes.
Yep. Inside that building, your question is chopped into standard tokens. Those tokens are multiplied billions of times by liquid-cooled GPUs chips originally meant for teenage video gamers running on raw megawatts of electrical power to guess the closest statistical neighbor on a map of language. And finally, the single most likely next token is shipped back to you, converting from light to electrons to pixels live on your screen.
And that entire journey, from keystroke to fully manufactured sentence, happens in the span of maybe 4 seconds.
The AI factory can manufacture a perfectly fluent, grammatically sensible blueprint for a complex question like, how do we become the safest city in America in just 4 seconds for a tiny fraction of a penny?
The author leaves us with one final, very grounded observation from his perspective as a community builder.
Yes, and I want to leave you to mull over this exact thought. The factory can generate the sentences, it can rapidly give you the statistical blueprint for the safest city, but no factory, no matter how many megawatts of electricity it consumes, and no matter how advanced its token processing becomes, can ever manufacture the human will to actually act on that answer.
That's the real limit.
The execution of those ideas, the messy real-world change that still has to be made locally, by hand, one neighbor at a time. Thank you so much for joining us on this deep dive into the physical internet. Next time you see those words typing themselves out on your screen, you'll know exactly what kind of heavy manufacturing is happening on the factory floor. Take care.